This video is about the chemistry of flaming gin on chemical reactions in stoichiometry. What is it about? Every day on social media, especially during the pre-COVID times, I can see people creating a cocktail drink called gin pom. It is a mixture of gin using Ginebra San Miguel Bilog, any flavor of powdered juice, cola, and water. However, before mixing the gin with the juice, cola, and water, they ignite the gin first. Further, shaking it then mixing every ingredient together. I asked some of them why they do this. They said it makes the drink more tastier. Thus, I came up with this idea as an output to my chemistry subject project, as I am confident that there is a chemical reaction in the ignition of gin and fire. This type of beverage is mostly known as flaming drink. Now, what is a flaming drink? A flaming drink is a cocktail or other mixed drink that contains flammable, high-proof alcohol which is ignited prior to consumption. The alcohol may be an integral part of the drink, or it may be floated as a thin layer across the top of the drink. The flames are mostly for dramatic flair. However, in combination with certain ingredients, the flavor of the drink is altered. Some flavors are enhanced, and the process may impart a toasted flavor to some drinks. However, you cannot make any drink ignite. There are certain factors, such as what type of alcoholic beverages you are trying to lit, and its alcoholic percentage. Research says that drinks such as vodka, gin, rum, whiskey, tequila are the only drinks you can put on ignition, and only if it has an alcoholic percentage of 40% and above. The images that you can see are real-time photos to what a flaming drink looks like. The photo itself shows that there is indeed a chemical reaction going, and that chemical reaction is really a part of our daily life. As mentioned, there is a chemical reaction happening between the ignition of gin and fire. Thus, there is a chemistry behind this. Let us begin with a stated fact that alcoholic drinks contain ethanol alcohol. Yes, this is the kind of alcohol that is being mixed in your alcoholic beverage. It is indicated in the bottle as 30% alcohol, 40% alcohol, 70% alcohol, or 80% alcohol. It depends on the type of drink you're going to buy. Ethanol, also known as ethyl alcohol, is a colorless flammable liquid that has a pungent taste. It is produced by fermentation, and it is the alcohol found in alcoholic beverages and used as a solvent. Again, ethanol is best known for being the alcohol mixed in alcoholic beverages. Ethanol is produced as a petrochemical through the hydration of ethylene and biologically by fermenting sugars or glucose with yeast. Ethanol has also many uses besides being mixed with your beverage. It can also be used as an additive to fuel that is used in your automotive mobiles, vinegar, feedstocks, and hand sanitizers, the one that we are using in disinfecting our hands during this pandemic. Ethanol is an organic chemical compound. It is an important industrial chemical and mainly used as a solvent. Its molecular formula is written as C2H5OH. Moving on, as we can see on the screen, on the left photo, that is the gin that is being used. And on the right photo, that is the ignition when fire is in contact with gin. The components of gin are water, sugarcane ethanol, and juniper berry compound. Juniper berry compound in gin is used to flavor the gin and makes it tastier. With this information, there are questions now that must be answered. 1. What is the difference of sugarcane ethanol from ethanol? 2. What is the empirical formula of sugarcane ethanol? 3. What is the balanced equation from the reaction of sugarcane ethanol and fire? 4. What kind of chemical reaction took place? And 5. How does the burning alcohol or flaming drink lower the liquid content of gin or the drink, creating a tastier and richer drink by being condensed? Let us now answer question number 1. Are they the same or are they different? The answer is none. There is no difference because they are just the same compound. Why? There is no difference in ethanol and sugarcane ethanol as both were fermented via a petrochemical process, either from glucose, also known as sugar, or other types of certain overripe fruits to make ethanol alcohol, as it is a byproduct of the metabolic process of yeast. Number 2. What is the empirical formula of sugarcane ethanol? Answer is C2H6O. Ethanol is also known as a 2-carbon alcohol. Number 3. What is the balance equation for the reaction of sugarcane ethanol and fire? To answer, ethanol or its molecular formula C2H5OH plus the molecular formula of fire, which is 3O2, yields to 2CO2 plus 3H2O, which is carbon dioxide and water. Thus, ethanol reacts with oxygen to yield carbon dioxide and water. To create a chemical reaction, you need 1 mole of ethanol and 3 moles of oxygen. Then it produces 2 moles of carbon dioxide and 3 moles of water. Ethanol molecules evaporate from the container of ethanol and enter the bottom of the flame. Evaporation is a physical change that transforms liquid into gas. When ethanol evaporates, its molecular structure remains the same. Oxygen atoms inside the ethanol join forces with oxygen molecules in the air to help ethanol burn more completely. Ethanol can lose a proton from the hydroxyl group and is a very weak acid. It is weaker than water. Thus, answering number 4, that the type of reaction took place is combustion. We are now down to the last question. How does the burning alcohol or flaming drink lower the liquid content of gin or drink, creating a tastier and richer drink by being condensed? The answer is, ethanol was converted to carbon dioxide and water, in which the latter is vaporized. Therefore, the water content in the drink is lowered, making the flavor more condensed and making it a more tastier drink. In conclusion, there is indeed a chemical reaction happening found in flaming drinks, and this chemical reaction is called combustion. It does not exist only for dramatic flare effects, but it is proven that it could enhance the flavor of the drink because the water content in the drink was lowered, making it more condensed. However, since alcoholic beverages contain ethanol alcohol, which is flammable and somewhat a toxic chemical, the individual should consume this kind of beverage moderately and with caution, even with the fact that ethanol is fermented from glucose, also known as sugar or fruits. To summarize what I have been discussing and the information that I have provided, and also this will serve as a recap. Ethanol, also known as ethyl alcohol, is a colorless, flammable liquid that has a pungent taste. It is an important chemical as it can be used differently, not only being an ingredient to our beverages. But even though that we can drink this, or this is a part of our drinks, we must also be reminded that this is also toxic and this is also hazardous because it is flammable. It depends on how or what is reacted to this chemical. Ethanol is produced both as a petrochemical through the hydration of ethylene and biologically by fermenting sugars or other overripe fruits with yeast. Its molecular formula is written as C2H5OH. Next, since it is proven that there is indeed a chemical reaction that happened between the ignition of fire and gin or ethanol plus oxygen, the ballast equation to this is C2H5OH, which is the formula for ethanol, plus O2, which is the formula of oxygen, yields to CO2 plus H2O. Ethanol reacts with oxygen to yield carbon dioxide and water. To create a chemical reaction, you will be needing 1 mole of ethanol and 3 moles of oxygen. Then, it produces 2 moles of carbon dioxide and 3 moles of water. The chemical reaction that took place was called combustion. There is a change of taste in the flaming drinks due to the water content being lowered because it was vaporized, thus making the drink more condensed. And lastly, this proves the point that chemistry is not only limited within the perimeters of our school or in the laboratories, because we definitely encounter it daily even during our leisure times. That ends my discussion. Thank you very much for listening, and I do hope you have learned something. Continue to stay safe.